CNS Engineering College for Women, Hyderabad. Today I am going to discuss DES algorithm. DES means Data Encryption Standard algorithm. DES algorithm is a symmetric block cipher. What does it mean? Symmetric cipher means same keys will be used for both encryption and decryption. Block cipher means it is not going to take bit by bit or byte by byte input. It is going to take a group of bits as input. What is the size of that group of bits? What is the size of that input block? It is 64 bits. DES algorithm will take 64-bit plain text and it will generate 64-bit cipher text. And it will take 64-bit key. That 64-bit key will be converted into 56 bits and that 56 bits will be again converted into 48 bits. If you observe, we have 16 rounds and for each round we have to use 48-bit key, that is called round key, and that 48-bit key will be generated with the help of 56 bits. And here we are giving 64-bit plain text to initial permutation function, and in initial permutation function will perform some permutations and it will generate 64-bit output, and that will be given to round 1, and in round 1 it will perform some operations. Soon we will see what are the operations that will be performed in round 1, and it will generate 64-bit output. Likewise, we will process 16 rounds. After 16th round it will generate a 64-bit output, and that 64-bit output will be given to a 32-bit swap function where there is 64-bit will be divided into 32 bits and 32 bits. Left hand side 32 bits and right hand side 32 bits, and that 32 bits will be swapped. That will give again 64 bits that will be given to inverse initial permutation. As we have performed initial permutation, so we have to perform inverse initial permutation, which will generate 64-bit cipher text. Okay, let's see what will happen in initial permutation. Let's consider our plain text. 64 bits will be arranged like this, and if this plain text is given to initial permutation function, that will generate bits like this. The position of the bits will change like that. This is about inverse initial permutation. In inverse initial permutation, the position of the bits will change like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15, 16. Like that, the position of the bits will be arranged. What will happen in each round? As we have 16 rounds, what will happen in each round? Let's see. 64 bits will be divided into 32 bits and 32 bits. Left hand side 32 bits, right hand side 32 bits. Right hand side 32 bits will be given to an expansion permutation where 32 bits will be expanded to 48 bits so that it can perform exclusive OR operation with the round key. Our round key size is 48 bits. After performing exclusive OR operation, it will send to a substitution box. We will call it as S box, where that 48 bits will be converted into 32 bits. Why? Because already we have 32 bits. So we need only 32 bits. So that 32 bits will be given to exclusive OR function where it will perform exclusive OR operation with left hand side 32 bits. And it will generate 32-bit output, that is our right hand side. And what about left hand side card? That is simply the 32 bits from previous round.